Okay, guys, today we're going to have a little conversation about functions and graphs. Um, we don't want to get too far along before we have this conversation. We need to make sure that we're all on the same page when we start referring to graphs and functions and the terminology that goes along with them. Some of the lingo that's important that as I use it in class that you're understanding what I'm talking about. Now let's not forget we're still in the first unit of the school year. This fits broadly under the main unit learning goal that we've been working on in this expressions category. It's kind of a nice way to tie things up before we move into solving equations. So the specific targets that we want to focus on for today are that you can interpret graphs of functions and you can draw graphs of functions. Okay, so a lot of this will be terminology and understanding what we're looking at. Some of it's common sense, some of it's review. So let's just go through and make sure that we're all clear on some things. Number one, we know that the center of a graph, whether it's a first quadrant graph or a second or a four quadrant graph, I should say, we always call that center point, which is represented by the coordinate. I can't do that. Black. 0, 0. We always call that the origin. Okay. We also know that when we're talking about coordinate graphs, the vertical axis, okay, this axis right here, is called the y-axis. And the horizontal axis is called the x-axis. Now this is important because when we start to talk about things like domain and range, we're going to relate those things to whether it falls on the x-axis or the y-axis. And there are some common ways that usually things are done that we want to be aware of. Okay? So so obviously over here we have another definition, ordered pair. We sometimes call these coordinates. In this particular textbook, they're going to use the ordered pair phrase. Those are kind of interchangeable. So it's important that when we look at a graph, we understand what we're looking at and that we can decipher the graph. I always tell everybody right away that if I took this away, and maybe you didn't even look at it before I was able to block that out, you really would have no idea what this is about. This whole thing, you might be able to tell me about numbers, but you wouldn't be able to relate it to anything. Okay, this has nothing to do with anything until there's a title on your graph. Okay, as soon as there's a title, then I can start to piece together what's going on. So now I have a title, blood flow after concussion. I have a couple of things I want to point out. Notice that we have now this is the vertical axis. Now I'm going to draw these in, even though they're not technically drawn in. I'm not going to do it in white. So if this is the vertical axis, this would be considered, put an arrow at the end, the y-axis, correct? We just got done talking about that. That's the y. And then we have an x-axis right here. So we're just kind of going along with those terms that we just talked about. This little point right here is considered the origin. That point would be considered 0, 0. Okay, so we need to be able to explain what this means. So as we look at this, we have 1, 2, 3, 4, 5, 6, 7, 8. We have days labeled on the x-axis. We have percent blood flow labeled on the y-axis. And what this is telling us is that blood flow after a concussion, probably I'm assuming back to the brain, after a certain number of days starts to increase, which means the longer the time after the concussion, the more blood flow the brain is getting. Okay? So obviously, doesn't that make sense? If you have a concussion, you usually have to sit out for a while until blood flow is completely coming back to your brain, and then you don't have any more symptoms. Couple things. Let's focus on this little thing down here. This happens. I'm not sure if you guys have seen that before. When you see a little squiggly line like this as a break in one of the axes, whether it's X or Y, usually what that means is that most of the information is going to be up here. So they did not want to spread this out and waste all that space on the graph. Sometimes you'll see that. It's almost like a jump because we want things spaced out evenly. Notice how it goes from 0 to 1 to 2. Every block, every mark represents 1. Well, here I have every mark represent from 50 to 75. So 25 is represented by 2 marks, but down here from 0 to 25, it's represented by 1 mark. That's just a way of saying, hey, this isn't to scale down here at this part of the graph. Just know all the information is going to be above it, okay? So in this case, you have to know that when we look at the points on this line, these are coordinates represented on this graph. So if we follow this one and we can see at 2, Number C is probably around 80. That means that x value, because remember in every coordinate we have an x and a y, so the x is 2 and the y is 80. That coordinate, or that ordered pair, means that after 2 days, 80% of the blood flow is back, okay? In a second, we'll talk about independent versus dependent variables. Usually the independent variables fall along the x-axis, the dependent variables fall along the y-axis, okay? So the independent variable here, these are the variables, these labels, okay? So I don't know anything about a graph unless I see, number one, a title, and I see variables. Those are the two things that we always focus on. You've got to have titles, you've got to label your variables. So in this case, which one is the independent variable? Which one is the dependent variable? Well, there's a couple of ways. I mean, I can just tell you and you can remember it. But the independent variable is the one that doesn't depend on the other, okay? Most oftentimes you'll find that if one of the units is some form of time, whether it's minutes, hours, seconds, days, years, time waits for no one, okay? So time is usually independent of anything. Usually things are more dependent on time. So in this case, on the x-axis, and this is a tip, because the independent variable is always labeled on the x-axis, number 1, so that's a tip-off. But if you think about it, days is a way to represent time, okay? It's how much time has gone by. So x-axis, so days, is the independent variable. On the other side, we have the y-axis, which in this case, the variable there is percent blood flow. So what that means is the percent blood flow back to the brain is completely dependent on the number of days that have gone by, which is independent, okay? So remember that the x-axis is where, or the horizontal axis is where the independent variables live. The y-axis is where the dependent variables live. So if that's not confusing enough, we gotta take it one more step, okay? Because we like to use fancy words. So we're gonna use the word domain and range. So when I say to you, what's the domain? What I'm referring to, domain, is basically referring to the independent variable values. Or in other words, the x's. And the range is representative of the dependent variable values. Or in other words, the y's. So if you ever get confused, so what I would say in this case, the domain is, now you can list a range of numbers, you can list specific numbers. Your teacher will probably be specific on how they want you to do it on a particular problem. But in this case, the range, since I get back to 100% within 6 days, you could say that the range is between 0 and 6. Maybe you say the range is between 0 and 8 because that's what's listed on the graph. The range on the other side, I meant domain, that's what I was talking about. The range, on the other hand, goes from 50 up to 100. Now, I would presume, based on a different case, maybe if you had a really severe concussion, you don't have 50% blood flow, it's even lower. But the bottom line is, in this particular case, the lowest number is 50%, the highest number is 100%. So you'd say your range is between 50 to 100%, or you may want to pick out those specific numbers, say 50, 80, whatever they are, up to 100, okay? So that's the difference. Another quick way to remember this is if you can remember that a coordinate is always x first, y second, and if you just know your alphabet, and you think of D as domain and R as range, D comes before R, just like X comes before Y. The domain matches up with the X, the range matches with the Y. That's a little trick to remember it if you forget. Analyzing graphs. You got to be able to look at things, and they're not always distance graphs. You know, when you start in middle school, we do a lot of distance graphs. You have to pay attention to what the variables are saying. So if this dependent variable, in this case, is speed, which is the y-axis, this is x, here's time. We're not talking about the distance away from something. So just because this goes up and then levels out and then comes back, that doesn't mean it's going away, stopping, coming back. In this case, because this vertical axis, this y-axis, is representing the actual speed, that means that starting from point 0, this line, this steepness, means it's increasing in speed up to a point, and then it's stable speed. It doesn't stop. It just means that the speed stays at whatever this mark is. Say this is 15 miles per hour. It stays at 15 miles per hour, and then it starts to slow down until it comes to a stop, which represents 0. Okay? So you got to pay attention to what these variables are so you can analyze what the graph is actually telling you. Here's an example. It says identify the graph that represents the altitude of a space shuttle above Earth from the moment it is launched until the moment it lands. So let's think about this for a second. This one, we're talking about the height above the ground versus time. So if we look at the middle one, it looks like you're starting off, you're at ground floor or sea level or whatever you want to call it. You're on the floor, on the ground. You're going to increase altitude, and then all of a sudden you just maintain that same altitude. This one looks like you blasted off and just stayed in orbit. This one, at time 0, you're not even on Earth. This one looks like you're already in space, in orbit, then you decide to come home. So it must be graph A, where it looks like you're starting on Earth. If the altitude is 0, if that's what we're going to call Earth, then you're going to increase your altitude to a point, you're going to be in orbit, and you're going to come back. So it would be graph A. So here's an example of something that you're going to be asked to do. You're going to have to be able to pick out, you're going to make coordinates, you're going to have to put them on a graph, and then be able to identify independent variables, dependent variables, domains, ranges. So in this example, it says for every 2 pairs of earrings you buy at a regular price of $29 each, you get a 3rd pair for free. So make a table for the cost of buying 1 to 5 pairs of earrings. Okay, so $29 each. So at 1 pair of earrings, you're at $29. At 2 pairs of earrings, you're at 29 times 2, which is 58. At 3 pairs of earrings, they said you get the 3rd one free, so I'm still at 58. At 4 pairs of earrings, you've had 1 free, so it's not 4 times 29, it's 3 times 29. So at that point, we're at 87, and then at 5, that would be 116. So the question will be something like this. Write the data as a set of ordered pairs. We know what that is. Then graph the data. So we know that one of the coordinates will be 129. The other will be 258. The other will be 358. The next one will be 487. And then finally, you'll end up with 116. Now, the question, which of these is the dependent variable, which is the independent variable, and where should we list those on our graph? Okay, because now I have it over here. We can kind of work in your way through this with me. But think about it. Which one of these is dependent on the other? Doesn't the cost depend totally on how many pairs of earrings you buy? So the number of earrings that you buy is independent of anything else, which means it must go on the x-axis, and that's why it's listed down here on the x-axis. The cost is completely dependent on the number of pairs of earrings. So this goes on the y-axis, which is the vertical, okay, and there's your cost. So all you have to do, let's remember how to, and this is just a first quadrant graph, but you remember at 1, we're at 29, at 2, we're at 58, I'm just ballparking this. At 3, you're also at 58, so it kind of slows down. At 4, you're at 87, and at 5, you're at 116, okay? Now, a lot of times we have a tendency to want to do this. We want to go do like this, and like this, and connect that line. We're used to doing that. But in this case, it doesn't make any sense to do that, okay? Because I can buy 1 pair of earrings. I can buy 2 pair of earrings. But have you ever been to a store where you can buy just 1/2 of a set of earrings, just 1 literal earring? Not usually. They come in pairs, right? So you can't buy 1 1/2. So any of the information between 1 and 2 is irrelevant. We don't connect that line, okay? That's what we call a discrete function because its graph consists of points that are not connected, okay? In other situations, everything between 1 and 2 and 3 matter, okay? So I would connect the line, and then that would be considered a continuous function. Okay, so remember that. They'll ask that question, whether something is discrete or continuous. And we'll talk about that in the last example, which is coming up right here, okay? So last one we'll talk about. This one says, and this kind of brings a lot of this all together. Mr. Ohms tutors students. He works at most 120 hours for $4 per hour. So identify a domain and range for the situation. So we have money that he's going to earn, and we have hours. So if you remember what we talked about, any measurement of time is usually going to be the independent variable which goes on the x-axis. The money in this case, how much you earn, is completely dependent on the hours you work. So that would be the dependent variable on the y-axis, okay? So remember, the y represents the range, and the x represents the domain. So hours, number of hours represents the domain, number of dollars represents the range, okay? Now we can take that further. If you're going to work at most 120 hours, doesn't that mean that your domain is going to be 0 to 120 hours? Right? Those are the possible values that you could plug into your domain, which is going to be on your x-axis. What about dollars? Well, we have to do a little math to figure this out. If you did 120 times $4, how much money would you make? You would make 120 times 4, which is $480. So your range might be between 0 and 480. Okay, so that's how you list your domain and your range. Now I'm going to go to the next page. I have a graph done out for us. Remember some of the things we just talked about. We've already identified that the independent variable will be hours, which represents the domain. That's going to be on the x-axis, which is the horizontal axis. The dollars, or the amount of money earned, is going to be on the vertical axis, which is the y, which represents the range. This one's the vertical axis, okay? That's the y. Horizontal is x, okay? So let's see what we got. There it is. I have a title. Need a title. I have my y, or my dependent variable labeled, total money earned. I've got my independent variable labeled, which is number of hours. Now all I have to do is figure out what to plot, okay? Now in this case, it's steady rate. I don't have to go crazy and list all kinds of points. But the bottom line is we know that if I work 0 hours, I make 0 amount of money, $0. You don't work, you don't get paid. The alternative to that is if I worked the full 120 hours that I said I can work up to, then at that point, I would make $480, okay? So maybe I'm over here somewhere. And at this point, I am going to connect this line. Now what you can do is you can pretty much estimate anywhere in between how much money you're going to make. If you're talking about 80 hours, well sure, you can do 80 times 4, but if you go up, it should be pretty close to where you're at, right? $320. So this line is a straight line, and I have an arrow after it, even though he said he's going to work at most. So let's be specific. I could probably do this and get rid of that arrow. Maybe if I make this big enough, we'll just cover it, okay? So that's pretty much how this goes. Now the question is, remember that concept we talked about, discrete versus continuous? What would this be? Would this be a discrete graph or a continuous graph? The answer you should be thinking about is it's a continuous graph, because it's not, you don't just work 1 hour and then work all the way up to 2 hours and not get paid any money until you work that full 2 hours, right? You can work a half an hour, you can work 15 minutes, you should get paid for every minute or however they want to do it, but you don't just get paid on the hour on that mark, okay? That wouldn't be fair if you worked an hour and a half, but they wouldn't pay you anything in between here. They only pay you this and this. Then no one would do that extra half an hour work. So it's continuous, okay? So anyway, these are some of the things that, it's continuous. These are some of the things that we have, that we're going to address in this lesson. This is the last lesson in this unit. We're getting ready for the unit test. But some things that I think probably some of this was review that you've seen before, but I just want to make sure we're all on the same page as far as terminology, understanding functions and graphs. So that's it for this time.